Howdy y'alls, it's the Diabolic vTutor again, and we're going to be continuing graphing the polynomials. Last time we left off, we couldn't get to the looking at the graphs and figuring out what are the potentially matching functions for the equation for the graph on the left. But I think we're going to start with like a little bit of review, and then we'll move on to looking at those graphs in particular. So here we are. And we're going to do maybe a little bit of review first. Well, not maybe. We're definitely going to do a little bit of review first. Alright. So given factors, let's say we're already given something in fully factored form. What's going to be the graph of that thing? So suppose we have f of x. F of x is equal to, we have x minus 3 times x plus 3, and then times, let's do something easy, let's just put an x. Oh no, I put on the wrong layer. Whoops. What up? Pardon me. Oh, layerings. Alright, this is the correct layer. Okay, good. So start off with f of x is equal to 2, and then we have x times x minus 3, x plus 3. So given this particular function, how do we graph this one? We have fully factored form already, so we ask ourselves what can possibly produce 0 from this entire function. Like, given this function, how can we produce 0? And then we're interested in producing 0 because we want to figure out the x-intercepts, so that will make it conducive for graphing. Yes. So first question is, how many factors do we have? We have factor number 1, factor number 2, and then factor number 3. So again, how can we possibly make 0? Well, that's fairly easy for the first factor. If the factor here is 0, then it doesn't matter what the rest of these things are, because 0 times anything is going to go 0. 0 times any discrete number, I should say. Alright, so that's the first factor that we can possibly make into 0. That means that we have an x-intercept at x is equal to 0. So xy coordinate plane, we have 0, 0. Because again, if you plug in 0 into your function, you will produce 0 as your y output. Okay, next factor up we have, I should not have crossed these out. Whoops. Always mistakes. Okay, so first 0 is x is equal to 0, and then second 0 we have here, how do we make this particular factor into 0 if x is equal to negative 3? Because again, negative 3 plus 3 is going to produce 0, and 0 times other two factors will produce 0. So that's going to be our second. I should stop underlining so much. Now produce our second. I was going to say next. That was a Freudian slip, right? Our next x-intercept will be here at negative 3. So brilliant. And our first x-intercept was there in no particular order. And then lastly, we have one more right here. And then how we produce 0 using this particular factor if x is equal to positive 3. Because positive 3 minus 3 gives us 0. 0 times other two factors produces still 0. So that's going to be our third x-intercept. We've successfully plotted all of the x-intercepts, and now all we need to do is consider the end behaviors for our function. And that one, we can just get that through partial distribution. You could sit there and you could multiply this entire thing out. You can get x squared plus 3x minus 9, and then you can multiply this one to each of those four terms. But that's simply a waste of time because we only care about the leading term for the situation, because leading term dictates the end behavior of your function, because it grows. It's the term that grows the fastest when your x values are very high. So subsequently, you don't need all this extra work. In other words, we can simply just do partial distribution. So instead of doing the full distribution for a 2 by 2, you can just simply take the highest degree term in here and you multiply to the highest degree term in there, which is just going to be this x times that x, thereby yielding x squared. And then we have this distribution into that one. So we're going to get x cubed as our leading term that we care about in order to determine the end behavior for our function. It is an odd powered exponent. It has a positive 1 coefficient in the front, so therefore end behaviors are going to be like this. Because again, if you cube a large size negative value, it's still going to be negative. So as x approaches a very large negative value, then y also approaches a negative value. And then on the other side, for the other end behavior on the right hand side, you can imagine that if you take larger and larger values of x, and if you cube those, the y value also becomes larger and larger. So summarizing that part, we can say that as x approaches positive infinity, y also approaches positive infinity. Alright, so getting to graphing, of course, we have, I should use this as brown, yeah, okay. So again, we have this kind of a down-up motion from left to right end behaviors. So starting off down here, we have a downwards one right here, and then we're going to do the old loop-the-loop like this. You must hit this intersection right here, and then loops back. I'm just going to cut it off. It's probably doing something like that. Whoops. Okay, there it is. Okay, and then we make the end behavior go upwards forever. So we have this down-up motion matching up what we've already specified should be happening to the end behaviors. And then, of course, we have the 3x intercepts dictated by these three factors. So we are done graphing f of x. Alright, but what if we have something a little different, but like mostly the same thing? What if we have x power 2 here, for example, and then we still have x minus 3 and then x plus 3? I keep saying it backwards. I keep saying x minus 3, but I write x plus 3. I think because this one gets a negative. Alright, so suppose we have something like this. What's going to be the situation? So we have here a 0 still at 0. So x is equal to 0. We'll force this entire thing to be 0. Zero product property will yield 0. So that's our first 0. Plant it at 0, 0. X-intercept. And then second 0 is still going to be the same thing as before. It's going to be at negative 3. So plant that right there. And then, of course, the third 0 is also the same thing. We have a 0 at positive 3. So you plant the x-intercept right there. Alright, but what has changed, of course? Well, there's a squaring up here, so we call that one a multiplicity. So this factor here is repeated with a multiplicity of 2. So repeat it twice. And what that does for our situation is we end up with a parabola motif, because isn't this just like y is equal to x squared? When you graph y is equal to x squared, doesn't it just look like this? This kind of a down-up motion. First it goes up, decreasing values, you hit your x-intercept, and then it goes back up for your standard parental parabola. I'm really mashing up my words today. If it's not one problem, it's another problem, right? Yesterday I was forgetting my signs, and now I'm just stumbling over my words. It is what it is. Alright. So again, we have this parabolic motif right there. And these ones are the same degrees as the previous problem, just degree 1 and then degree 1. What that means is we're just going to have a straight up intersection. This is going to be a pass-through motif, like a linear function. So if you look at this one, and then you decide to graph it on your xy coordinate plane, it's just going to be something like this. Kind of a straight through passage through negative 3. And you're going to see the exact same thing when you graph this one. So let's check that out. Oh wait, but first we need to determine the end behaviors. We could do partial distribution. We have the greatest degree term on the outside. It's just one term. So we can distribute that to the greatest degree inside the parenthetical number 1, and then we're going to get x cubed. You distribute that one to the third factor, the greatest degree term in there, thereby getting x to the power 4. So again, partial distribution to figure out the leading term. We have this one here times this one, and then times that one, getting x power 4. This is an even powered exponent. It's going to be a positive coefficient, positive 1 coefficient in the front. So therefore, we have the upwards parabola-like end behavior motifs. Upwards, upwards. So from here, it's going to upwards, and then there we have an upwards situation. Because again, we want these end behaviors to agree with what we just figured out. Reason being, since this is the leading term, if you take a large negative value and then you raise it to the power 4, it's going to be positive. So as x approaches positive infinity, as x approaches negative infinity, then the y value also approaches. I keep saying also, but y approaches positive infinity because the negative one is negated by this even powered exponent. All right, and then we have on the other side, we have as x approaches, for this side, we have as x approaches positive infinity, y still approaches positive infinity. Because again, if you take a larger and larger values and then you raise them to the fourth power, they are successively getting larger and larger positive as well. Hence these end behaviors right there. And then we just need to beautify the situation. Make sure you pass through x-intercept number 1. It's right here. It's odd multiplicity, so again, it just shoots through like a linear function. So there it is. And then we have the next one. So this is going to be the wrong thing. Don't do this. Or don't do this, I mean. Because this one has a multiplicity of 2 on the x factor. So it's going to do a parabola-like motif right here. So when you're swooping in from this part right here, you have to do the old touch and go like a parabola. Parabolic motif, like this. Because again, even multiplicity gets you parabola-like motifs. Okay, and then of course we're going to swoop back around, then passing through this x-intercept right there, and then connect back to the end behavior, and then we are good to go. That would be the graph of the function of this f of x, and we are good to go. Moving forward, of course, we have h of x. It's going to be mostly the same thing yet again. It's going to be x squared times x plus 3. Now this is going to get squared, and then this one's just going to be x minus 3. That's before. So now I've upticked the multiplicity for this particular factor. So what does that do? It's just going to get another parabolic motif. So first 0 is at 0, 0. And then, first x-intercept is at 0, 0. And then second x-intercept is at negative 3. Same situation. And third x-intercept is at positive 3, 0. Alright. Figuring out the end behaviors, we have greatest degree is x squared. Distribute to this one. But remember, this one right here, you need to partially distribute the 2 to this one first. Because the greatest one you can get from here, yes, it's indeed 1. But this is repeated. So you have to multiply times x power 1 to get rid of to account for the first factor. And then for the second factor, there's another one, so you have to multiply by another x. And that takes care of both of those factors. And then lastly, we would distribute this entire chunk to this one. Just to make this one clear, if we were to write it all out, so this one, we can keep it consolidated as this. This one, you technically need 2. And this one's just 1. So the idea is we take this one, you multiply to that. That's this one. And then you multiply to that. Then you multiply to that one. Or you could just use a shortcut. So you could just distribute it partially to this one, thereby getting x squared, and then you could distribute it to that one. And then lastly to this one. We're still going to get the same answer. X power 5. Don't forget your exponential rules. Same bases. All you need to do is summate the exponents. We therefore have a leading term of x power 5, which means we have the down-up motif. As with all odd-powered polynomials, it's going to be the down and up because it has a positive coefficient of 1. So no sign flips. Alright. So now that we know that, we have to have something down here and then something up there. The old down-up motif. We have a parabolic-like motif at at 0, 0 right here because of multiplicity 2. Even multiplicity means you have parabolic motif. And then we have another even exponent for this particular 0, which means we're going to have a parabolic motif right there. So parabolic motif, how do I know it's pointing down? Because we must connect it to the end behavior. Like that. So if we had drawn it instead upwards, then how can we connect it without introducing a new x-intercept? Which we don't have. We only have 3 unique x-intercepts. So we must, this parabola-like motif must be going downwards to connect to this one. Agrees with the end behavior now. Now then we have another parabolic motif right here. So again, does it go upwards or downwards? Again, if you go upward, you cannot connect these two without introducing a 0 that's not there. So this parabolic motif must be going downwards, like so. Okay. And of course, this goes off the page. It might be doing something like this. So we are finished with this one, and we finished with that one. And now lastly, we just need to account for the third x-intercept located at 3, 0, right there. And that's pretty nice. We're going to go downwards. We're going to loop back. Pierce right through. I can draw this properly. There you go. I can connect it with the end behavior motif right there. There it is. Well, that looks kind of funny. Okay, perfect. And again, I do like to chop off these parts because I don't want to commit myself to where the bumps are going to be. Like, is it right here or is it like way down here? I don't know. We're not going to do calculus at this point. Alright, so that should be the graph of h of x. It's right there. And again, make sure you account for these even multiplicities with parabolic motifs. And then this one is odd-powered exponent 1, so it just passes straight through. If I change this to exponent 3, it would not do much for the look of the graph, because this is still going to be odd-powered exponent. As such, it's going to pass straight through right here. Same thing. Because again, odd-powered. It's only when you have even-powered, then you do like another motif thing. And this would change the entire end behavior as well. So if we put 2 here, then we have x squared times x squared times x squared. So it's x power 6. So that one would change its end behavior to pointing downwards. And then we also get the parabolic motif right here instead. Alright. And then we'll just do one more thing, of course. There's a review. Let's do h of x. Let's do g of x. So g of x is equal to x power 3, multiplicity 3, times x plus 3 squared. And then lastly, we're going to have 3 minus x to the power of 5. So the question is, how do we graph this junk? It's going to be the exact same zeros as before. We have x-intercept at 0, 0. X-intercept at -3. And then x-intercept at, how do you make this into 0? Positive 3. So same thing. Positive 3, 0. Alright. And of course, we need to figure out the end behavior for our function. Just do partial distribution. So from here, now this is where you need to be careful. This is an odd-powered exponent. So if you partially distribute, you need to distribute to this negative x. So if you have negative x to the 5th power, it's still negative. So from this one, the greatest possible term with the greatest degree is negative x power 5. And then from here, the greatest one is still the same thing. X power 2, partial distribution, and then this one we're just going to get x cubed. So if you multiply those three greatest terms possible from each of those factors, we are going to get, number 1, negative 1. And then just summate the exponents, x power 10. So what has happened? This is even power exponent, so it's either going to be up, up, or down, down end behavior. But since we have a negative in front, that means we have the downwards, downwards trend. Because again, if you raise a negative value to the power of 10, it's going to be positive, but you make it negative, hence downwards. And then if you have a large positive value, if you raise it to the power of 10, it's still positive, but it becomes negative, accounting for that end. All right. So now that we have the end behaviors, we know that's going to be going down, down. So let's go through the motions. Here, again, this is the first 0 from left to right. It's multiplicity 2, so it has the parabolic motif at negative 3, 0. So here's negative 3, 0. We have the parabolic motif right there. Just move this over to beautify. Something like that. So we are finished with this particular factor, and then we have this one. It's going to be odd multiplicity, not even. So this one is just going to be strike through like a linear function. So here we're just going to strike straight through. How do we know it's not like this? Because you have to connect them. You have to connect it from here to there somewhere. If you start negative and you end up positive, you have to cross the x-axis. So we can't have that. So it must be like this. Again, going off the page. Let me redraw this. Something like this. Alright, so we've accounted for the blue factor, and then now we have the last one, which is this. The x-intercept has 3, 0. It has a multiplicity of 5 odd-powered exponents, so we're just going to pass straight through. Here it is. We're just going to pass straight through. So make sure you connect those ones like that-ish. Something like that. And then connect this one smoothly to that one. So let me cheat a little bit by moving this. There we go. And then we're basically done. Let me delete this part because it looks kind of ugly. But understand that it does go loop the loop like that. Or not loop the loop, it just is one loop. Okay. And that's it for this particular graph. We are done with g of x. And all of that was that. Wait a minute. Yeah. Okay. So let me just change up a few things regarding this one. Just for the purposes of discussion. So what if this had been instead x power 6, for example? Well, number one, the partial distribution will have changed. If this is going to be a multiplicity of 6, we partially distribute to this entire negative x. But the negative will become eradicated because this is an even powered exponent. So it will become positive x power 6. So this whole thing changes. It will have changed to x power 11 with a positive coefficient of 1 in the front. So now just basically change the end behaviors, so it won't be going downwards anymore because this is an odd powered exponent with a positive coefficient, so it goes down up motif. So we would instead be aiming upwards. And because we now have even multiplicity on this factor, that means we have the touch and go motif, the parabolic motif right here. Something like this. This is just for visual completeness. Let's just do this. So your graph looks something like that. If I change this to a 6. which means we can get started with these problems now. We have here, enough of the review, we have for each scenario, which functions, if any, are consistent with the graph to the left. Now be very careful, because the way this is written, this is parenthetical s, so there might be more than one function. And then this one tells us that there might be no functions that are consistent. So let's go over this one just to see how the flow of the problem. Let's start off with the easiest one, of course. Here we are. So let's first evaluate A. So what's going on? Well, there are multiple ways you can begin to do these problems, but let's just go with checking the factors first. So this is factor number 1, which means the 0 is at -7, which means we have x-intercept at -7, 0. It is a multiplicity of 1, so that seems kind of good, right? Pass through. And then for second factor, we have a 0 at -3, so there it is. It's an odd multiplicity, so we should just be piercing right through. So this is consistent with this one. And then that one is consistent with that one. And behaviors, we're not sure yet. And checking a little farther, we have this particular 0. Is it consistent with this one? The 0 is +1, so yes, that is consistent, and it has a degree 1. So pierce through, yes. And then lastly, for this example, for this A option, we have a 0 at +4. It's right there. Again, multiplicity 1, so pierces right through. Yes. So all of these zeros are correct. Let's check the end behaviors by doing partial distribution. So here we go. We have x times -x times +x times +x times negative in the front. So the two negatives right here, right there, will cancel out. Thereby, we are going to get x +4. So is this consistent? Yeah, looks pretty consistent to me. Because x power 4 has the upwards motif for the end behavior. So this one, yes, and then this one, yes. Everything is an odd multiplicity, so it's just going to be pierce through, pierce through, pierce through, and then pierce through. So A is good, so yes. Circle that. All right. So that's just going more in depth. In fact, sometimes there are some strats that are easier than other ones. Now that we know that all of these ones are correct zeros, we can kind of use it to check the other problems. So these ones are consistent, 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 not consistent, because we have a multiplicity of 2 at this location. So this is at +4, 0 right there. According to this one, a multiplicity of 2, we should have a parabolic motif. But we don't. So this one is cause for elimination of choice B. You could also check end behaviors as well. So if we have x here, we have x here, we have -x, and then we have partial distribution right here. If you square -x, it's +x squared, and then we have times the -x, and then times x. So if you crunch the numbers right there, where you get -x power 4, no, x power 5, I mean, which has conflict with what we already have right here. So this is pointing upwards. If you have a negative on an odd powered, it's going to be doing this particular end behavior motif. So this was, yes, that is in agreement, but this one goes down, this one goes up. So conflict. So again, we have you can have two different reasons for eliminating choice B. Number 1 is the easier one in my opinion. It's a multiplicity of 2, which means we have a parabolic motif right here, or like this or like this. But we don't have that on the actual graph, so B is wrong. So checking choice C, what do we have right there? Well, we have the same 0 right here. Yes, same 0, and then same 0. So we might be tempted to say this is correct, right? But always check the end behavior motifs just to make sure. So let's see. We have x times -x and times another -x. So these two -x's will cancel out to become +x squared. We have 2x squares right here. So in grand total, it's x power 4, which is consistent with upwards. So C is also a good choice. Yes. In fact, C is the exact same thing as A, because if you take this negative and you distribute it to that one, you will transform this one into 4 minus x, which matches that one. Okay. So again, A is correct. A is consistent with this one. B is not consistent, and then C is consistent. Checking D, what do we have? We have the same zeros, right? Yes. Consistent. But this is degree 3, right? This is degree 1. But that should be fine, because if you have odd degree, it just passes right through, like so. Well, let's double check to make sure that the end behavior is still consistent. So we have partial distribution. If you distribute 3 exponent, odd exponent to negative x, you're going to get negative x cubed, because negatives don't cancel with odd powered exponents. We have a negative x here. So partially distribute to this one, partially distribute to that one, partially distribute to that one. These two are x squared. So if you multiply this out, number 1, it becomes positive 1. And then number 2, 2 plus 1 plus 3, x exponent 6. So that is the upwards motif, which is consistent with this one and this one. So D is also consistent with the graph on the left. So there's a quick disclaimer. I did not put any hash marks on the y-axis, so that's why A, C, and D are able to be consistent. If you actually had the hump right here, and then we actually had some coordinates, like for example, this is like coordinate 10, then some of these will become potentially wrong, but I make no commitment to what's happening on the x-axis. Yeah. Like I said, I'm not committing to how low this is or how high this one is. So subsequently, these options could be correct. Consistent with this. Okay, next one up. Sometimes it's just easier to check end behaviors, honestly. It depends on the situation. So this is a up-down motif. So we know, since this is alternating up-down, then we know we have an odd leading. Well, we have an odd exponent for the leading term, and then the leading term is also negative since we have a flipped up-down rather than down-up. So again, we have a negative, we have some sort of negative coefficient in the front, and then we have some sort of x term with an odd exponent. So let's just do partial distribution to check those ones. We have x cubed times this one, and then 2 distributes to there, we get x cubed, x squared. So these two multiplied to become x4. Don't forget the negative in front. So if we crunch if we do the operation right here, first things first, we have a negative. Yes, 4 plus 2 plus 1. So that is indeed consistent, right? But we need to check the zeros, of course. So we have a 0 at 0. Because again, 0 cubed gives us 0, and then 0 times the rest of this factor will produce 0. But here's the thing though, this is multiplicity 3, but we have the touch and go pattern, the parabolic motif right here, so that gives cause to eliminate choice A. So choice A cannot possibly be correct, because this is multiplicity 3, this is here supposed to be multiplicity even, not odd. Because if we have multiplicity 3, then it's supposed to be doing the straight pierce through like a linear function. So that's wrong. Moving on to B, of course. This is the one that is corrected, because now we have a even multiplicity, so we have the parabolic motif like this or like this. So this is consistent. And then we have a 0 at negative 3. It's odd multiplicity, so this pierce through is correct. We have an odd multiplicity at positive 3, 0. So that is pierce through is correct. And then lastly, Lastly, we have even multiplicity on the 6. So because it's even, it's supposed to be doing the parabolic motif, but the graph that we're actually given is a pierce through, so this even multiplicity is wrong, which allows us to eliminate choice B. Alright, so A is inconsistent because of that factor, B is inconsistent with the left graph because of this factor, multiplicity. Checking choice C. Choice C is, what do we have? We have a 0 at 0, that's correct. We have an even multiplicity, so this is consistent so far. That one, we have a 0 at -3, but according to this one, it has a multiplicity of 2, which is inconsistent with this pierce through, so we know this is wrong. We don't need to check the rest of this. C is wrong. Moving on to choice D. Choice D has a... Wait, let me delete this first. Alright, in the choice D we have even multiplicity at this particular 0, so that is consistent. Yes. Consistent motif. And then at this particular 0, we have multiplicity odd. That is consistent right here. Next one up we have odd multiplicity at 3. So 3, 0 is a pierce through. Yes, this is consistent so far. And lastly we have odd multiplicity. That's good because we have a pierce through right here. But let's make sure we check the end behaviors now. So is it correct? Let's do partial distribution. So this one yields x squared, and then we do partial distribution of this. And that one is just x power 1. And this one is negative x. So if we do the partial distribution completely, 2 plus 3 plus 1 plus 1 gives us 7. So negative x power 7, which is in agreement with our first assessment, where we have an odd exponent with a negative degree in the front, negative term in the front, so it's going to be up down, which is consistent with the up and then the down. So choice D is correct. It's consistent. Alright, moving on. We have this maroon looking function. It's kind of funky. Be careful about this one. We have an even multiplicity because it's the parabolic motif. We have an odd multiplicity. We have even multiplicity. We have odd multiplicity. Odd multiplicity. End behaviors is a down up, so we know that we have a positive x with an odd exponent because it has this standard motif. Alright. Let me keep that. Let's not delete that quite yet. So we're supposed to have even multiplicity on this one. So this is going to be x minus, or x plus 3, and then we have even up here. And then for the other one, right here, we're going to have x minus 3 with an odd multiplicity. Everything else, I'm sorry, even because that's the parabolic motif. I misspoke. Alright, so let's check. So this is already in fully factored form, so let's just check this one. Yes, that's present. Yes, it's even. Okay, so that one is consistent. Yes. Checking this other motif, other factor, we have x plus 3. It's supposed to be even exponent. Yes, even exponent. Sounds good. And here is where we see the wrong thing. Right here, this is x minus 6. That's 6. This is even multiplicity. Then it's supposed to be doing the parabolic motif. This is not the parabolic motif. So this is wrong. Thereby allowing us to eliminate choice A. That's gone. Okay, let's just take a quick peek. So this one is consistent because it's even. This one is consistent because it's even. This one is inconsistent because it's odd. We're supposed to have even. So this one is wrong, which leads to this is wrong. Okay. And of course, we have b and c left over. Let's just make sure the other exponents are correct. Everything else, aside from those two, right? Everything else will have an odd exponent. Yes, yes. Yes, yes. Yes, yes. So the only thing left we have to check is the end behavior, are the end behaviors. And we could probably eliminate one of these choices. Alright. So according to B, what's the end behavior supposed to be? Partial distribution, right? So we're going to distribute that to that to that to that. So there we have, don't forget the negative, x cubed times x squared. Not just x power 1. It's x partial distribution squared. Partial distribution also times x squared. This is just x power 1. So that's looking bad already because we have a negative. This is supposed to be positive. So if you evaluate that, we're going to get negative x power 3, 4, 5 plus 4 is 9. So yes, this part is correct. It's odd, but this is supposed to be positive because it's down, up. This one says it's up, down. So giving us cause to eliminate choice B. Which probably means that choice C is correct, right? But don't assume that, because for these problems, if any, so we should double check the end behavior for this one. Alright, so checking the end behavior, this one distributes, partial distribution. This is just exponent 1. So exponent 1, exponent 1, exponent 2, exponent 2, exponent 1. So doing the full evaluation, 1 plus 1 plus 1 is 3, 3 plus 4 is 7. So that is consistent with what we first determined. So C is consistent with this graph. Perfect. And now it gets kind of annoying because these ones are already in fully factored form, right? But this one is not in fully factored form. That is what we get. Too bad. Alright, let's see. Let's just evaluate end behaviors. This is going to be upwards, upwards. So partially distribution. So we're going to get x power 4. And then distribute to this one right here. We're going to get exponent 5. And then distribute to that one. We're going to get negative exponent 6. That's a negative even exponent, which means this will be going down, down like that. But, whoops, this is supposed to be what we get with the graph for the end behaviors for this one. Is that what we got? No, it's up, up, not down, down. So therefore this is incorrect. Therefore this is incorrect. Okay, that's nice. Checking this one real quick, right? Using end behaviors, so partial distribution. Yes, we get x power 6, which is consistent. So we cannot eliminate B right off the bat. And then partial distribution here to that one, because again, we're ignoring the lower degrees because this one doesn't dictate end behavior. It's going to be this one times that one, which is also exponent 6. So C, we can't eliminate. So checking this one real quick, we have x squared times x squared times x squared, exponent 6. So that one is also consistent with the end behaviors. So we have no choice but to check the zeros. Checking the zeros, we have a 0 at 0, 0. It's an even multiplicity, so that's correct. I guess we got no choice but to factorize this junk, right? So factorizing this one, thereby getting x factors of 8, 16 that make up 8. Oh, this is a perfect square trinomial because half of this is 4. 4 squared is 16. So x plus 4 squared. That means that even multiplicity at negative 4, is that what we have? Yes. So this part is consistent so far. And then lastly we have this one. This is not a perfect square trinomial, so let's factorize this junk. So factorizing this one, factors of 18 that summate to be 9, 6, and 3. Both positives, yes. Okay. Are these consistent? Let's double check. So again, this one is consistent because of the even powered exponent, so that motif is correct. And we have exponent 1, so that's going to be the pierce through at -6. Wait a minute, wait, what? We don't even have a 0 at -6. So because this one doesn't even exist on our function graph, then this one B is incorrect. Okay, we don't even need to check this one. Oh, this is also incorrect. Wait a minute, this is like a +3. We don't even have a -3. Yeah, it should be right here as well, so we don't have that. Okay, so multiple reasons why B is wrong, but you only need one reason to disqualify it. Alright. Checking C now. What do we have? Oh, we can factor something from all three terms, so thereby getting x squared factored out from here, here, and here. It's kind of cramped, isn't it? So once we factor out the x squared, this one becomes x squared plus x minus 12, which itself is further factorizable. Factors of 12 that add up to be +1 is x plus 4 times x minus 3. Okay, I might as well factorize this one as well. So factors of 24 that add up to be, factors of -24 that add up to be +2. What's that? 8 times 4, 6 times 4, 6 times 4. X plus 6, and then x minus 4. Do we have any repeated factors? Yes, right here, which is consistent with that one. Yes. Let me delete this. I think I misspoke. This one right here is a 0. X-intercept at 0, 0, multiplicity 2. So that's consistent with this one, yes. We have a factor at, we have a 0 at -4, multiplicity 1, which is inconsistent with this one. Because this odd power means pierce through, but we have parabolic. So given that information, that means that this one is wrong. This one cannot be true because we have parabolic motif. C is thus eliminated because this one is -4, not +4. If this one had been +4, we can consolidate those two, getting x plus 4 squared. Then that would have been consistent with this. But that's not what we have. We have -4, not +4. Alright, so choice C is also eliminated, which tempts us into thinking this one is correct, right? Maybe. Well, we shall see. Let me double check my work for this. +6 minus 4 is +2. Yeah, that's correct. Yeah, this one tells us that there's a 0 at x is equal to +4. We don't have such a 0. So this is wrong. Doubly wrong. Checking the last one, right? What do we have? This one right here factorizes into factors of -12, that would be -1, -4, and -3. Factors of 18, that summate to be -9. What is that? -6, -3? Yes. Factorizing, oh, that one's easy. Just factor out x from those two. That's bad, it's multiplicity 1. But finishing it up, we have x minus 6. Okay, so what do we have? Well, first thing, that's even multiplicity, x minus 6 squared. Because this is even multiplicity, we're supposed to have parabolic motif at +6. +6 is here. That's a straight pierce through. So this one eliminates it. Additionally, this is exponent 1. and yet we have product motif, so that's also inconsistent. Not that we needed two reasons. But now that we do have two reasons, then choice D is clearly wrong, so none of these are correct or consistent with this one. Unless I messed up. I don't think I did. Alright, making good progress. Let me see how many are left. 4 more. Okay, not too bad. So next up we have this particular problem right here. What do we have? We have down up. So we have odd exponent, and since it's up down, it's going to be negative leading term with an odd exponent. So let's check that real quick. So we have this one partially distribute to this, to negative x, to x squared. So what do we get? Well, first things first, this one right here is negative x squared. Distribute to that one is x cubed. What's still negative? Distribute to this one is negative x power 4. To that one, negative x, remember. So this gives us positive x5. Lastly, so becomes exponent 7, which is, hold on, Ruby's knocking on the door. I'll be finished. Yeah. Knocking? Okay, it's probably dinner soon. I'll finish up soon. Alright, so we have, again, positive leading term, which is inconsistent with negative, so that allows us to eliminate choice A. Let me double check that real quick. So hopefully I'm not being sloppy. Negative x power 4. The negative cancels with negative, gives us positive. This is still positive, so this is in disagreement with the up-down motif. Okay. So, firm confidence that A is incorrect because it has the wrong end behaviors. Checking choice B, of course. Partial distribution. X power 4, and then we have x power 2. And then we have a negative x power, ooh, this is bad, 2 plus 6 is 8. This is even, this is odd, so choice B is also incorrect. Ruled out choice B by end behavior situation. So this has got to be correct end behavior, right? Yes, we have a negative x power 7. Which is consistent with this one, but that doesn't mean choice C is correct. It just means that the end behaviors are consistent. We still need to check the factors for this one. We'll check it afterwards. And then, of course, choice D, we have a negative, and then we have x power 7, which is consistent with this up-down motif. All right. Ooh, this looks really annoying. Wait a minute. That's fine. Okay. I was going to say something. Alright, so we have to check choice C, and we have to check choice D. Wonderful. But let's make a few notes. We have an even multiplicity at the 0, and then we have an even multiplicity at the 0. So whatever this is going to be x minus 6. It has an even multiplicity. And this one also has an even multiplicity. So let's use these ones to test. Choice C and choice D. Alright. I think from this one we can factor out x squared from 3 terms in the front. And that would be consistent with this one. So let's do that first. So factorization. We're going to x squared outside. X squared minus 12x plus 36. Okay. So again, this one is consistent with this one. Yes. Good to go for that. Is this good? Well, what does this factorize into, right? It factorizes into x. Half of 12 is 6. 6 squared is 36. This is perfect square. So this is x minus 6 squared. Is that consistent? Oh, it is consistent. So this is consistent with this one. Alright. which means we just have this left over. And unfortunately, this is kind of annoying, right? So do we have to resort to doing the work of Descartes' rule of sign, extracting the coefficients, and then doing syntactic division? No. Here's the reason why. We already have our 0 candidates to test because they're present here. So we have a 0 candidate here, there, and there. So let's keep track of those ones. We have a 0 candidate at -7. We have a 0 candidate at -4. And then we have a 0 candidate at +3. So rather than doing guess and check, we could just simply extract these values and jump straight to the syntactic division. So let's do that. So 3, 2, 1, 0. So let's extract the coefficients as all terms are present and accounted for. So again, our first 0 candidate, arbitrarily, I'm going to select 3 because that's the easier number to work with. You pick -7, you can, but I'd prefer not to multiply by 7 or 4 because 3 is easier. So pick your battles. 3, drop that, multiply, sum, product, sum, product. Is that correct? So you get a 4, 8. Yes, this is consistent. So this one is correct, yes. But we have two other numbers to check, -4 and -7. So if these two are indeed zeros of our function, then it should work as we continue our syntactic division. So let's continue with the -4. Oh, you know what? This is actually a quadratic. We could just do our factorization for quadratics at this point. So that is basically, I want to factor out negative sign from each of those. X squared plus 11x plus 28. Factors of 28, that have to be this one, 4 times 7. That is consistent, right? We have a -7 and a -4. So this is consistent. Let's zoom out real quick. Summarize. So this is consistent with that because it's odd multiplicity. Yes. And then we have green factor. -4, 0 is exponent 1, and then that is consistent with the strike-through motif. Yes. We have here the x power 2, which is consistent with this one. Yes. And then for the positive 3 location, we have this one right here, which is technically x minus 3. Exponent 1, consistent with this one. Yes. And then we have the magenta. Multiplicity 2, which is consistent with this one. We already checked the end behaviors. The end behavior, what was it again? It was x power 4 times x power 3 with a negative in front, so negative x power 7, which is consistent with our first up-down evaluation. So yes, choice C is a good choice. This is wrong, wrong, consistent. So what about this last one, right? Well, yeah, it's kind of annoying, but we could do the same strat as what we've done before. We can just check for consistency. So the easiest one to check for is this one first. Can we factor out x squared from all of these terms? Yes, we can. So factor out the negative x squared first. So what do we get? Cleanup step. X power 5 plus, this is where I have to be extra careful with my signages because I botched those up last time. Sign flip. Downtick by 2. 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 Okay. So we have this junk right here. This is consistent with that. So yes, that's good. As for the other ones, well, it becomes kind of a difficult. So this one right here, let's just check that one. I think I changed the color, but it doesn't matter. So again, this one means a 0 at positive 6. So x minus 6 is supposed to have an even multiplicity. So let's just check it with this one. Where do I put the space? Let me think. I wish there's a way to just cover this. Hold on. Let me think. Oh, you know what? Too bad. I can't do it. Let's extract the coefficient. 5, 4, 3, 2, 1, 0. These coefficients are... Let's just extract those because all terms are present and accounted for. This is going to get really messy. So we're testing 6. It should work at least twice because this is even multiplicity. So 6 here. How do I do solid fill? Let me think. Let me try something real quick. Whoops. Not what I wanted. Wow. Okay, I keep messing this up. I just need paint bucket for that. Yes. Okay, perfect. Alright. See, I know how to draw. Alright, let's do this evaluation. So dropping the 1, multiply, sum, multiply. Now to be careful for this one. If it was 67, it would be 20, but we don't have 67, so we have 19 only. Alright, multiply. This is so annoying. 120 minus 16 is 114. Okay. So summating that one, ooh, this is really annoying. So if this had been 13, we would have negative 100. But we do have one extra, so it's negative, it's negative 99. Yes. Alright, multiplying that one. Wow, why are these numbers so annoying? We have 6 times 100, which is negative 600, but we have to remove 1 6, so it's negative 594. Summating those ones. This is more straightforward. 2, 5, 2, negative. Multiplication, that is a good ending. Carry the 1, 31, 3, and then 6 times 2 is 12. 12 plus 3 is 15, negative. So that is consistent so far, but we have an even amount, so 6 as a candidate should work one more time. Let's see. At least one more time. So drop the 1, 6, sum, multiply. Ooh, this looks kind of bad, doesn't it? 6 times that one. What is that? Ay, 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 ay. My brain can't process. 102. Summating. Okay, this looks like it's not going to work out because 6 times this one is a whopping 600. Over 600, right? And if you summate that, that's over 500, right? And then if you multiply that, that's already 30,000-ish, which is way over what this is supposed to be. So 6 doesn't work a second time, which means we only have 1 6 as a 0, which means we only have x minus 6 exponent 1. But that is incongruent with this idea, which tells us that we have an even amount. So therefore, choice D is wrong. So only choice C is consistent with the left-hand graph. All right, 3 more to go. Right off the bat, we could already see choice A is wrong because of the end behaviors. We have an up-down motif, so that means negative as a coefficient. And odd-powered exponent, you can already see that this is a positive exponent, so choice A is already wrong. All right, what else do we have? Partial distribution, this one times this one yields x power 6 with a negative coefficient, but this is already wrong because according to the evaluation, it's supposed to have it's supposed to have an odd exponent because we have the up-down motif. This is, with the negative would be down-down. So just by looking at n behaviors, we can eliminate choice A and choice D. Yes. All right, so what do we have? We have this one. Let's see the n behavior real quick. Yes, yes. So we have a negative in front. And 2 times 2 is 4. 4 plus 2 is 6. Plus 1 is 7. So B is consistent with the n behavior. It doesn't mean it's correct. It just means it's consistent. And then choice C, is it consistent? We have this times that times that. 2 plus 2 plus 2 is 7. I'm sorry, 2 plus 2 plus 2 is 6, plus 1 is 7, so negative x power is 7, which is consistent with this one. So choice C is consistent with the n behaviors. So let's check the zeros. So that's fun. Don't forget this thing. Difference square number 1, square number 2. So thus factorizes to 4 minus x times 4 plus x. Okay. So there's that one. And then we have here, got the awkward squaring, but let's just factor this one first. So we have x minus 2 times x plus 2. And we call this brackets. So this whole thing is getting squared, so we could just do distribution of exponents. So this is a square, multiplicity 2, multiplicity 2. Finally, we have this x minus 7. Nothing to do with that. So let's check to make sure that these are correct. So these ones are two different zeros. These are two repeated zeros, and one unique zero. So this one is consistent with this one. Yes. We have a... Let's check this one. Color that orange. So at the positive 2 motif, we're supposed to have an even multiplicity. So this parabolic motif is correct, is consistent. So that's good. Let's check this positive 4. So positive 4 is here. It's one multiplicity. So yes, that is consistent. Now let's check the negative zeros. That sounds funny. Negative zeros. Okay, so this one at negative 2, we have an even multiplicity at negative 2. Negative 2, we have a parabolic motif, so that is consistent. And lastly, too many colors at this point. What have I not used? Like a dark purple, right? Yeah. Yeah, dark purple. So this has negative 4 with an odd multiplicity pierced through. Yes. So all the zeros are consistent, and then the n behaviors are also consistent. So therefore, choice B is consistent with the graph. Okay. So choice B was good. And then choice A is wrong because of the n behavior. This is wrong because of n behavior. So we're supposed to have negative x power odd. We already checked n behavior for C. It's consistent. Let's check the zeros. So this one. This is a perfect square. Half of negative 4 is negative 2. Negative 2 squared is 4. Just following the algorithm for that. Alright, this one right here, factors of negative 14 that summate to be negative 5. What do we have here? We have x minus 7. You can kind of cheese it because we could borrow factors from other problems. Alright, and then we have 2, so x plus 2. Alright, takes care of that one. And then for this one, what are the factors of that? X factors of 8, 4, and 2, that would be 6. Yes. And then lastly, this is already in fully factored form, so let's start piecing things together. So we have even multiplicity at the positive 2. Yes. So that is consistent. And then, wait a minute. We have this one times this one. That consolidates. Let me use magenta. So this one and this one consolidates into x plus 2 multiplicity 2, which is parabolic motif. Yes, that's correct. Consistent, I mean. So that is consistent. So we're done with checking that one and checking that one. We're done checking this one. All right. Let's make sure the other things are also consistent. Motif, we have a odd powered exponent, so that's just pierced through. So this one is consistent, yes. What do we have left over? We have this positive 4. I'll keep that as orange. Exponent 1, so at negative 4 we're supposed to have pierced through. Negative 4, yes, pierced through. Consistent. And then lastly, 4 minus x. I'll use that dark purple. So dark purple for exponent 1, so pierce through. So have we accounted for all the zeros? 1, 2, 3, 4, 5. Yes. So all the zeros have been accounted for. They're all consistent, and then the end behaviors are also consistent. So therefore, C is a good answer. It's consistent with the left-hand graph. Yes. Cool. All right, and then we have this one right here. Again, sometimes it's just easiest to check end behaviors first. We have a down, up, so that's odd. And because it's down, up, then it's going to be positive in the front. So let's see. Partial distribution times the x cubed, so that's x power 7. So that is consistent. And behaviors are consistent for choice A. Choice B. Nope. Right off the bat. This is even powered. We need odd powered. So choice B is already eliminated because of the incorrect end behavior. Because again, exponent 6 is up, up, like so. Checking this one, we have cubic times squared, so that's x power 5, which is consistent with this one, yes. So we can't eliminate C right off the bat. Choice D, at least not based off of end behaviors. Choice D. We have this one times this one, which is going to be x power 5. So that's also consistent with the end behavior. But I think this is called the fundamental rule of algebra. Basically, the amount of intersections you have should also add up to be 5. Let's see. So you have at least one solution here, at least one solution there, at least 2 solutions here, at least 1. So 1 plus 1 plus 2 is 5. Okay, that's consistent. So we can't use fundamental rule of algebra, I think. Alright, that's fine. Let's check this one. So we have to factorize this junk. So we have an x squared here and an x squared there. So we can factor out x squared. Thereby getting, what was that? Thereby getting x minus 4. X squared is consistent right here. Yes. Even powered motif. Yes. We have a negative, a 0 at positive 4 multiplicity 1. Right there. That is consistent with odd multiplicity. Yes. Checking this one, of course. There's a 2 outside, but let's take care of the inside first. Factors of 12 that add up to be 8 is just 4, and just 6 and 2. 6 and 2. So this part is just this inner part. So if we consider these as brackets, there's still a squared on the outside. So we can distribute that to each factor. Distributive property of exponent, this becomes 2, and that becomes 2. Is that consistent? Doesn't look like it. This is degree 2 on the negative 6. At the negative 6, it's a pierce through, not a parabolic motif. So because of that, this is wrong. This one is inconsistent with this location. Alright, moving on to choice C. Same strats, we're just going to break it up. So this one factorizes into what? 6 and 4? Yeah, 6 and 4. So x, different signages, greater than 2 is positive, so plus 6 minus 4. This one right here, we can factor out the x from each of those. I think it's wrong now. So we have only factor x with an exponent of 1. I think that eliminates this choice. So again, this one has an x, well, only one x term that we can factor out from each of those. So we get x power 1. And since this one doesn't have any x power 1s that we can factor out, therefore the multiplicity is only x power 1. That's even multiplicity. So choice C is wrong for this thing right here. So that probably means choice D is correct. Maybe. Let us find out. Okay. So let's delete this part. So is choice D consistent? So this one factorizes into x minus 4 plus 2. Yep. Oh, we can only factor out an x from each of those. So times x, divide by x, divide by x. Now this part isn't totally necessary since this is only degree 1. But just to be complete. So again, no x terms hiding here. I'm sorry, no factors of x hiding from those two. No x factors from those two. So we only have multiplicity 1, which is again inconsistent with multiplicity even right here. So because of that reason, choice D is also wrong. So there are no functions that are consistent with this one. Alright, moving on to this one. Oh, that's a real pain right there. But hopefully we can eliminate that from using end behaviors. We probably can. This is going to be up, down end behavior. So therefore, negative x power with degree odd. This one is odd, but it's positive in front. So thankfully, we don't have to deal too much with this nonsense. So we need a negative odd exponent. This one does not give it. So C. So choice A is inconsistent. Let's check choice B. Partial distribution. Partial distribution. Partial distribution. Partial distribution. Partial distribution. Now be careful about this one. It's cube of a negative x. So that is going to be times negative x cubed. Multiply it out. 3 plus 3 is 6. That's a 10. That's a 17. So negative x power 17. Is that consistent? Yes. So this one we need to check a little bit more. Checking choice C now. This is wrong for the same reason choice A is wrong. This is going to be a leading positive term, but we need a negative leading term, so this is inconsistent already. Last choice, distribution. Careful about signages. Alright, so that one is also consistent. Negative x power 7. Which is consistent with our evaluation. So we only have two choices to check, choice B and choice D. All right, let us see. So we have we do have some odd multiplicities right here and right there, and I think those ones are consistent. So this one is at -4, odd multiplicity, so it's a pierce through, so this one is consistent. This one had -2, also odd multiplicity, pierce through, so this is also consistent. We need to factorize this junk. So then is a perfect square trinomial, so half of this is -2. -2 squared is +4, so x minus 2 squared. What's this junk? Half of this is -4. -4 squared is +16, so this is also perfect square. Wait, was it positive? Negative. So it's going to be x minus 4 close parentheses squared. This one is what it is. Alright, let's check the consistency. So that one is at positive 2, multiplicity 2, so it's supposed to be parabolic in nature. Is it parabolic in nature? Yes, it is. So this is consistent. Same thing right there. It's supposed to be parabolic motif at positive 4. Yes. Consistent. Lastly, let's use dark purple. Lastly, we have odd multiplicity at 6 for the 0 right here. So strike through. That's consistent. So all the zeros are consistent. And the end behaviors are consistent. So therefore, since there's nothing else to evaluate, then choice B is consistent with this graph. So let's check choice D. Hope you remember your difference of two squares right there. So factorize that junk. X minus 2 times x plus 2. Negative in front. It's nice to cross things out so you don't accidentally relook at something. Factors of 8, 4, and 2 that summate to be positive 2. So greater than 2 magnitudes is 4. Smaller than 2 is 2. Is that correct? Yes, negative 8. Positive 2, yes. Okay, and unfortunately we do have this junk right here, but we can just use it, just use synthetic division to check our zeros. So what are we missing, right? So these two combine to make x minus 2 squared. This one is going to be x plus 2, x plus 4. Alright, let's see if those ones are consistent right off the bat. Well, technically this is a bad check because we don't know what's inside there. So we should probably factor that one first. Because here's what I mean. If we check this one, it's like, oh, that's an even multiplicity. And then you look here, yes, it is even. But what if this one reveals another x minus 2? Then that will be odd multiplicity, which will be inconsistent with this one. So don't just check this one straight off without figuring out the factors for this thing. So let us factorize this first. And we could kind of cheese it again because we know that we're supposed to have these candidates right here. So I'm going to check 6. Since none of these are 6, we're going to check the 6. So what do we have right here? We have 3, 2, 1, 0. So all terms are present and accounted for. So let's extract the coefficients. So be careless like I am. This is positive, negative, positive, negative. Okay. We're testing what again? 6. So drop the 1, multiply, sum, multiply, sum, right, 56, yeah, multiply. What is that? 6, 3 carry the 3, 6, 9. Yes, that is consistent so far. This is a quadratic at this point because this is exponent 3 divided by 1x takes you x squared. So use your favorite factoring method right here. This is a perfect square. Half of this is negative 4. Negative 4 squared is 16. So x minus 4 squared. Alright, let's make sure everything is consistent now. So just to keep the coloring consistent, let me put here x minus 4. Okay. So, oh, I almost forgot the 6. Don't forget this one right here. Alright. So let's check to see if everything is consistent. Let me delete these ones from the previous work. So let us check. So we have, starting with the leftmost right here, odd multiplicity, so that's a pierce through, so this is consistent, yes. And then checking the positive 2, odd multiplicity, so that's going to be strike through, yes, consistent. Checking right here, that's an even multiplicity, and we call that a green. So We have an even multiplicity at positive 2, which is consistent with this parabolic motif right there. So that's good. And then check this one next. We have even multiplicity on positive 4. Even multiplicity on positive 4. Yes, that is consistent. Good. Lastly, it's the dark purple. That's the first one we checked right here, right? So we have odd multiplicity. It's going to be strike through, so this is consistent. So all the zeros are consistent, and the end behaviors are consistent. So nothing else to go off of. So choice D is consistent with this graph. Okay, I think that pretty much sums it. We went through the entirety of this. So you see, not too bad. It just looks intimidating, but the evaluation is not too bad. The worst thing comes when you have to, test candidates. But luckily, you're not starting from ground zero. Like you don't have to figure out what are the factors of 1512 over factors of 1, because you already have your 0 candidates right there. All right. So I think that pretty much concludes it for today. At least for now. Maybe, I know I've been saying that maybe I'll stream later, but I haven't been doing it. So I may or may not show up a little later. But regardless, have a good one. Hopefully see you next time.